Today we are diving into the super important topic for anyone building or maintaining cloud solutions: high availability and resiliency in solution architecture. So, business can't afford a downtime, so there is impact behind the downtime. It leads to business losses and trust from its customer. So, high availability and resiliency is super important for any business. It can be a e-commerce, it can be a social media, or it can be your website. It depends. Now, planning for high availability and resiliency required 100% uptime and fault tolerance during the downtime for this application. So it comes from high availability. It requires a cost planning and architecture to be planned. So how the architecture design? It can design based on a requirement what that particular website has or an application has. For example, banking industry cannot afford outage for its client. It could be a super loss for them. But if you can say an e-learning industry, they can afford a downtime. An hour downtime in a month should be okay for them. But banking industry cannot afford an outage, not even an hour from entire year. So they are looking for 99.999% uptime, which is absolutely no downtime for them. And how can we achieve that? That is super important, to so we will understand how can we achieve that particular thing in next slide. So stay with me. An organization doesn't want to see a downtime. Application downtime can cause a loss for business and use trust of this user, which makes high availability one of the primary factor while designing the solution architecture. The requirement of an application uptime varies from application to application. For example, if you have an external facing application with large user base such as e-commerce or banking website or a social media website, then 100% uptime become critical. In the case of an internal application, for example, HR system or internal company application or blog can tolerate any downtime as I said in previous slide. A solution architect always need to plan high availability as per the application requirement to avoid user or architecting. To achieve high availability, it's better to plan workload in the isolated physical location of the data center, that if an outage happen at one place, then your application replica can operate from another location. As so in the following architecture diagram, if you have a web application server fleet available in two separately availability zone, which is different from physical location of a data center, the load balancer help to distribute workload between two availability zone in case availability zone 1 goes down due to power or network outage. Zone 2 can handle user traffic and your application will be up and running. In the case of database, for example, you have one database here and you simply can in zone 1, so you can set up a replication between zone 1 and zone 2, and in that case, you need to need human intervention to do some configuration in a database to make sure once your availability zone goes down. So this is nothing but a proactive approach as shown in the architecture. The other proactive approach to monitor health of all instances such as CPU memory utilization, spinning up the new instances as soon as one of the instances goes down or reach to the threshold limit. As the CPU goes higher than 10% or memory utilization goes more than 80%, the attributes of high availability and resiliency can help in terms of cost by achieving elasticity. For example, if utilization is low, you can take out some of the servers and save a cost. The architecture goes down in hand while healing, where you can make sure that your application is up and running, but you also need to have a quick recovery to maintain a desired user experience. So this is how the architecture and solution normally works in. So uh, let's discuss the other points in next video. So stay tuned and keep watching my videos. Thank you, and make sure you subscribe and hit the bell icon.